welcome to the ultimate Docker crash course for beginners, developers, and DevOps engineers. By the end of this video, you will know exactly how to containerize your application, manage containers, and do more with Docker. What exactly is Docker? Docker is a platform that allows you to package your application with all its dependencies into a container. This ensures that the application runs seamlessly in any environment. Wait, why is this important? This is very important for efficiency, portability, consistency, and more. Okay, and what are the real-world use cases? In real world, Docker is used for deploying web apps in the cloud, for running microservices, streamlining development environments. In general, when we talk about Docker, we refer to the technology that runs containers. However, there are some things to be aware of when we talk about Docker as a technology. Okay, when we talk about Docker as a technology, we talk about the runtime, the Docker engine, also known as the daemon or server, and also the orchestrator. But now that we actually have the basic knowledge of what Docker is, let's see how we can install Docker into our computer. To install Docker into your computer, simply go to docker.com, and here you will see this download button. Okay, so simply download and install the one that suits your computer. Alternatively, if you don't want to install Docker on your computer, you can simply go to Play with Docker, click the first option, click on Login, open this Docker, and here you can simply sign up or log in if you already have an account with Docker. You will see this Start button. Okay, click on the Start button. Okay, and now we have this particular session. Note that if you are using Play with Docker, you have 4 hours. Okay, so after these 4 hours, this session is going to end. To start using this, you can simply add a new instance. And now we are ready to learn and play with Docker. So we've seen 2 ways in which we can install Docker into our local machine. For the purpose of this course, I will be using the Docker desktop. But everything we do will also be the same if you are using the Play with Docker. Now, if you've installed the Docker desktop, you can manually start the Docker desktop from the Windows Start menu. Simply go to your applications and look for the Docker. So you can open this, and now we have the Docker desktop opened. Good. Now that Docker is up, in our terminal, we can simply type some Docker commands. So if you're on Windows, you can open your command prompt. And if you're Mac, you can simply open your terminal, and here we can simply type Docker version. And here we see that the setup is working successfully. Congratulations! You can now run and manage containers. So we now have a working installation of Docker on our machine. Now let's look at Docker from ops perspective and also from a developer perspective. The first point is, when we install Docker, what exactly do we get? So when you install Docker on your machine, you practically get 2 things. Okay, as we can see here, we have the client and also the server. The server is also called the Docker engine or Docker daemon. Okay, the Docker engine implements what we call the Docker runtime, the API, and everything else we need in order to run our containers. We are going to understand this very soon. But by default Linux installation, the client communicates with the server. So the client talks to the daemon via what we call a local IPC or Unis socket. Okay. And on Windows, the communication happens via a named pipe. So the Docker version command we have here actually helps us to test that the client and the server are running and talking to each other. Good. I hope this is clear. So let's clear this terminal. And once you run Docker version, if you get this, it means that the client and server are running and they are communicating. So we are good to go. Next, let's look at what we call Docker images. So, what exactly is Docker image? We can simply look at Docker image as an object, okay? An object that contains an operating system file, an application, and all the application dependencies. So we say that the Docker image is simply an object that contains three things: an OS file system, an application, and all the application dependencies. So for a DevOps engineer, we can simply relate a Docker image to a virtual machine template. So in the Docker world, an image is like a stored container. And as a developer, you can simply think of an image as a class. Okay. So let's clear this terminal. Simply type Docker images. Hit enter. This command will simply list all the images we currently have on our Docker. If you are working from a freshly installed Docker host or play with Docker, you will actually see nothing here. Okay, this space will be empty in your case. No images. Okay, now if you open your Docker desktop, so if your Mac, you will simply see this icon here. Go to dashboard. Here you can actually come to this image, and on my Docker desktop, you see that I have Python and my SQL. So this place in your case should be empty. Next, let's look at how we can get images onto our Docker host. And we do this by simply typing Docker pull, and now we need to specify the name of the image. Okay, so let's pull the hello world image. Okay, so here we specify the latest and hit enter. Great. So now we have downloaded the newer image for the hello world. Okay, now you can simply type the Docker images again. Great. Here we now have the hello world with the latest tag. The process of getting images onto our Docker host is called pulling. We will get into the details of what exactly is inside the image and also where this image is stored later. But for now, it is enough for us to know that an image itself contains an operating system, the application, and all the application dependencies. And when we talk about application in this case, we refer to all the code, okay, all the code that run whatever application it is designed for. So the image contains the operating system, the code, and all the dependencies to run whatsoever application such image is designed for. Okay? Okay. Notice that each image has a unique ID. Okay. Here you see a unique ID for this Python image and also for other images. So we can actually reference each image either by using the ID or using the name of the image. Also, it is important to note that when we are referencing an image via the ID, we can easily type the first few characters and Docker will easily understand which image you are referring to. Now that we have basic knowledge of Docker image, let's look at what we call the Docker container. So first, let's clear our terminal. A Docker container is simply a runtime instance of an image. So it is a runtime instance of an image. Remember, we put an image locally, right? We can now use the Docker run command to launch a container from the image. To see this image again, we simply type Docker images and hit enter. And here we see this hello world that we pulled before. And remember how we pulled this image. Let's actually pull another image so we can easily understand what we are doing. So to pull an image, we simply use Docker pull, and here we specify the name of the image. Now let's pull this Ubuntu, then also let's use the at latest flag. Hit enter. Great. This image has been pulled successfully. And we can confirm this by simply rechecking the Docker image. Remember, on your terminal, you can actually see the previous commands using the arrow up, okay? So the arrow up or down. So Docker images, and now we have this Ubuntu at latest. Great. Now let's actually create a container. From this image. And to do that, we simply use Docker run. Let's use the IT flag. And here, let's specify the name of the image we want to create a container from. Okay, so here we say Ubuntu latest. Here you can hit enter. And when you look at the output from the command, you will see that the shell prompt has changed. Okay, so now we have an interactive shell. And this is because of these IT flags. The IT flags switch our shell into the terminal of the container. So now we are in the terminal of the container. Good. What about this Docker run? The Docker run simply tells Docker to start a new container. This IT flag tells Docker to make the container interactive, and here we tell Docker that we want this container to be based on the Ubuntu latest image. And this actually will list all running processes. So it's going to list all the running processes inside this specific container. This from the Docker run command, and also the PS process that we run to list the running process. Great. Now, how can we actually exit from this? How can we return to our normal terminal? To exit this container without quitting the container, we can simply press Ctrl PQ. Okay. Once you press Ctrl PQ, you see that you are back to your normal shell. Okay, so let's clear the terminal, and now let's run the Docker PS, and from the output, we see a single running container. We see that our Ubuntu is still running. Okay, and here we can actually see the time. Okay, this is up 5 minutes ago, and also we can see when we created this container. Okay, the next question is, now that our container is running, how can we reattach our shell to the terminal of the running container? Okay, so we actually want to reattach this shell to the terminal of this running container. We can do this by simply running the docker exec command. Let's use the IT flag to make it an interactive shell. Now we can specify the name of the container. Remember, we can also use the ID. And while using the ID, you can simply enter the first few characters. Docker itself will actually understand what we mean. And next, let's tell Docker to actually run our bash shell. So here you can hit enter. And now you see that we are back. Now you see that we are back to the terminal of the running container. So you can press Ctrl PQ again, and let's do the same thing. Docker exec, let's use the IT flag. Now, instead of using the ID, let's actually use the name. So here it is called the awesome class, and also let's specify the bash shell. Okay. And now you see that we get the same results. Okay. So you can actually use either the ID or the container name. It is important to pay attention to the format of the Docker exec command. So the Docker exec command, here we have the Docker exec, then we have the options, the container name or the ID, also the command that tells Docker to run the bash shell. Okay. Next, let's exit this shell. The next thing we want to look at is how can we actually stop a running container. Remember, to view the running container, you can use Docker PS. And now we have one container that is up and running. How can we stop this container? We can stop a running container easily by typing Docker stop, and let's specify the container name or the first few characters of the ID. Okay, great. Now type Docker PS. You see that we don't have any running container, but we can actually view the list of both running and also container that are not running. Okay, because if you check your Docker desktop, you will still see the container we curated from the Ubuntu image. Okay, so if you go to your Docker desktop, so open your Docker desktop and go to containers, you will still see this Ubuntu container. Okay, why is it that when we type Docker PS, we actually don't see any container? This is because the Docker PS command only shows us the list of running container. So if you want to see the list of all other containers, the list of all the containers, you have to put the flag A. Okay, and here we see the list of all our containers. So we still have our Ubuntu latest. Okay, let's see how we can actually kill this container. Remember, we stopped the container. Remember, we stopped the container using Docker stop. So to kill the container, we simply use Docker rm, okay, Docker remove, and we have to specify the name of the container or the ID. So in our case, we have the CFC P5, okay, and hit enter. Great. So let's type Docker PS again. And here you see we don't have the Ubuntu latest any longer. Great. Congratulations. You have just pulled Docker images. You started a container from the image. You attached your shell into the container terminal, executed a command inside the container, you stopped the container, and you deleted it. Great. Next, let's look at containers from developer's perspective. Containers, for a developer, container is all about application. So on my terminal, I will navigate into my desktop, and on my desktop, I'm going to create a folder and I'm going to call this Docker Dev. So now when you check your terminal, you are going to see this new folder. Okay. So you can actually do the same thing right from your terminal. And simply right click on your terminal and create new folder. Once you are done, open this folder in any code editor. So I'll be using Visual Studio Code. I'll simply open this folder inside a code editor. So from my terminal, I will simply type code dot. Now I have my project directory. So we can open a terminal here, and here I'm simply going to initialize a node project. Okay, and to do that, I will simply use npm init, and let's use the Y flag so we don't answer any question. And that gives us the package.json file. Okay, so we have our package.json file. Now let's simply install Express. Okay, so let's clear the terminal, npm install Express. Hit enter. This might take some time. We continue once we are done with the installation. In our package.json, we now have these dependencies, and here you see Express. Good. Let's create a file here and let's call this app.js. So this is going to be a very simple Express application. So here let's require Express. So const Express is equal to require Express. Good. And now let's create our application from this Express. So const app is equal to Express, and we need to call this. For this simple application, for now, let's forget about environment variable. So we don't have to install any .env. We can easily create a variable for our port. Okay. And let's call this 3000. So now let's call the app.get. Here, let's say API slash hello. And of course, this takes a callback in which we have access to the request and response. Okay. So in here, let's grab the response and let's actually use the JSON. And in this case, let's add an object with message of here, let's say hello from Dockerized world. And now let's simply call the app to actually listen on our port. So here we need to pass two things, the port and also a callback. And here let's simply console.log and we say server is running on port. And here we put our port. Good. Now, how can we actually test this project? So in our package.json, where we have script, so here let's say dev, and here we specify node app.js. Okay. So let's put comma here and save this file. So in our terminal now, let's clear the terminal and now we can run npm run dev. Okay, great. Here we get an error. Let's actually go to our console. So in the app.js, we can actually see where the error is coming from. So in our app.js, here we have a wrong spelling of console. So this should be console.log. And let's save this. And now let's clear the terminal and rerun this application. Okay, so here we get our server is running on port 3000. Great. We have successfully set up a simple Express application. And now, how do we actually see this particular message? So we can simply visit these routes on our ports. So let's open our browser. So in our browser, let's go to localhost. And remember, our port is 3000. Then we have to put /API/hello. Once we hit that, we should actually see the hello from Dockerized world. Now that we have successfully set up a basic Express application, let's actually see how we can containerize this application. So first, let's create a Docker file. Okay, so we can actually quit this and we can create this file either from here or from the terminal. So on the terminal, you can use the touch command. Okay, you can use the touch command and you specify the name. So it has to be spelled this way, Docker file. Hit enter. So now we have this file and now we need to tell Docker to use Node.js official image. And we do that by using this from command. So we say from node and we can specify a thing. Okay. So let me put some comments here. And to add comments into this file, we actually do this using the hash symbol. Okay. So the first file tells Docker to use Node.js. So use Node.js official image as the base. Okay. Next, we need to set the working directory in the container. So let's use a comment also. So here we set working directory in the container. And we do that using the work dir. Okay. Okay. And next, we need to specify the path. So here, let's say USR, okay, user slash the source slash app. So the next thing we want to do is to copy our package.json. Remember, we said that an image have access to all the code the dependencies, which is actually coming from our package.json file. So next, we have to copy package.json file and package lock.json. We do this simply using copy command. Very simple. So copy package star.json. Okay, either package.json or package lock.json. Then let's specify the roots. And next, we actually need to explicitly tell Docker to install the dependencies. Okay, so we tell Docker, please install dependencies. And we use the run command. So run npm install. And now we have to tell Docker to copy all other application code. Okay, so here we say copy, and we do that using the copy command. Okay, so copy dot dot. Next, we want to expose the ports that our application runs on. Okay, so let's put the command. Let's put the comments expose, which is the port 3000. So here we simply say expose 3000. And finally, we need to define the command to run our application. And we simply use cmd. Okay, and here we specify node, comma, then the name of the file, which is the app.js. And let's save this. Now we are done with our Docker file. Remember, the first line is to tell Docker to use the Node.js official image. Okay. Second, the workdel tells Docker the workdel sets the working directory in the container. Next, we copy both the package.json and package log.json. Okay, so these are the dependencies. And the next command tells Docker, please install all the dependencies. Then copy all our application code, expose the ports the application runs on. So we tell Docker that this application runs on port 3000. Okay. And then the final command is the command to run our application. Remember, here we use node app.js. Great. Next, let's create what we call the Docker ignore file. And the Docker ignore file simply helps us to avoid copying unnecessary files into the Docker image, just like git ignore. Okay, so we use git ignore to avoid moving unnecessary files into the remote directory, to the remote repo. Okay, so in Docker we use the Docker ignore. So here let's specify node modules and also npm debug log. So the next thing we need to do now is to build the Docker image. Okay, so let's open our terminal, and to build our image, we simply type docker build, and let's use the flag T. Then let's add a tag. Let's call this our node app. So we tag this image our node app. And now let's put dot. This dot actually specifies the current directory. Okay, this tells Docker that the Docker file is located in this root directory. Okay, you can see that here. Now let's hit enter. And here we see that Docker, we actually follow all the steps. Okay, great. So now we have our image built successfully. Good. So now let's actually run a container from this image. And we do that using Docker run. We use the p tag to actually map the ports on the container to the ports in our local machine. Okay, so here we need to specify the name of our image. And we called this our node app. Hit enter. And now we have server is running on port 3000. So simply we can now go to our port 3000. Okay, so here we type localhost. We specify port 3000. Remember, we have this API route, and here we specify /API/LO. So we have to enter exactly that. So we say /API/LO and hit enter. Now you have this message, hello from Dockerized code. Okay, so remember, this is what we send from our API. Okay, so congratulations. We've seen Docker now from a dev perspective. So now when you go to your Docker desktop, you should actually see this container up and running. So we can use the same command, Docker ps, to view the current running containers. We can use Docker stop to actually stop this container, and Docker remove to kill the container. So we have containerized a simple application by building it onto an image using instructions in a Dockerfile, and we ran the containerized app. I hope this video helps you to understand the basics of Docker and also crash the basic questions on Docker in your interviews. Please, if you found this video helpful, do not forget to like, subscribe, and drop a comment down below. See you in the next video on Docker Deep Dive. One love.